let's pay careful attention to some of the wording in this prompt. You've got we're dealing with average speed. So experiments have shown that when a dense solid object is near the surface of the earth, it is dropped from rest, it will fall freely y feet. So y is the variable that I want to use, okay, during the first t seconds, such that the distance of the object falls is modeled by f of t. Oh, okay, so we're going to use function notation. So this is the distance the object falls is modeled by this, right? So that is an amount that it fell. That is not a location per se. That is not a speed. That is an amount that the object fell. A rock breaks loose from the top of the cliff. What is the average speed during the first 2 seconds? And then explain why the rate is a positive value and not a negative. So obviously I know I'm going to try to get a positive value here. If I don't, I've done something wrong. We don't have great notation for this. So we're going to say average speed. I'll talk about a few other options a little bit later for that. But we do want to deal with the change in distance over the change in time. I need you to understand that we are still dealing with a slope. What is distance measured in? In this one, it's measured in feet, and the time is measured in seconds. It is very important that you pay attention to your units. The units are always going to come into play when we're dealing with these kinds of problems. Now, because this is an F, I'm going to use function notation. I could have used Y based on what they said, but I like this function notation a lot more. But not everything is always F. Sometimes it's G, sometimes it's H, sometimes it's S, right? So I'm going to have to pay attention to that. I want the change over the first 2 seconds. That is not from 1 to 2. That is from 0 to 2. So the change in the distance the object fell is f of 2 minus f of 0 over 2 minus 0. That is the slope formula. This is what I would refer to as f of b minus f of a over b minus a. Okay, that is slope at its finest. So I need f of 2. Well, if I don't have a calculator, it should be pretty easy to get. Notice how I label things accurately. So that's 16 times 4. So that's in feet, and then f of 0 is obviously 0. So I've got some values here. So 64 minus 0 over 2 minus 0. This is considered to be a difference quotient. This is considered to be a difference quotient. Okay, you're always going to have to show one of those. We prefer that you show them both. All right, so this is going to just reduce, right? So you have 64 over 2, which reduces to 32. You need a unit. Okay, this is in feet per second. This is a rate of change. This is a speed. All right, units matter. You are always going to have to attach units to your answer. Now, the last part of this question was explain why the rate is positive and not negative. I am dealing with a rock that is falling. Okay, so this is kind of a weird situation here. But remember, what is this measuring? This is measuring the distance the object has fallen. All right, so I really want you to pay attention to what the prompt is giving you, right? The distance the object falls. So this is very important because it leads into stuff that we do all year. Okay, the distance, I'm going to write a few things here. So the distance the rock is falling is increasing. Because if the rock falls, that distance that it fell is going to increase over the time frame, right? From 0 to 2, as long as it is falling on that entire interval. So that distance is increasing, i.e., I don't want to write that. I want to write getting further and further away from the starting position, away from the starting position. Because what I have here, the function is measuring the distance the object falls. You are always going to have to explain if something is increasing or decreasing, right? So I'm going to put, therefore, the rate is positive because the distance is increasing. Okay, that's why the rate is positive. If the distance were decreasing, or if I was measuring something else, right, then I would be able to have a negative answer. It is possible to get a negative velocity. On this one, we were dealing with speed because of this measurement, right? And so speed is generally positive. That's what we're working with there. But velocity can be either negative or positive.